So again, I already addressed this. I'm just happy that you are here. That's what matters. You're doing what's right. I have no idea about the other 16 people that are currently not here, but all right, that's your choice. Anybody have questions from homework or hold that thought for a second. Let me turn off my fan. All right. Good. How's everybody doing? Any homework questions? Any questions in general about anything? Does anyone come up with a new way to memorize the values you have to memorize? If you run across any material that you like if you find something on YouTube that explains these things really well, you can let me know. I can put it up on Canvas for other people. If you are not looking for other resources to help you, 176 is really like the class you really need to start doing that if you haven't already done it. I'm almost certain that some of you guys found YouTube sites that do a really good job of explaining some ideas and all that kind of stuff before. But this is where you really need to start doing that. This is where I started getting other textbooks that my class wasn't using, because one textbook would explain this thing really well, and then it would suck on the other things. And then this textbook would explain this thing really well. It's just the reality. It's just the author's way of explaining, meshing with the way that I see things. That's just the way it works for all of us humans. Right? So yeah, I keep forgetting that I need to sit down and create a list of resources that I've come across. But I don't know. To me, that's sort of a student experience thing. I don't want to make it seem as if I've gotten the best stuff, because it really depends on what makes the most sense to you, right? So there's stuff that I love that would make no sense to some people, because it's just the way I think of things. Oh, you're fine. Okay, so have I rambled on enough? Has anyone come up with any questions that you have? All right. I'm almost certain there are questions. And so what's really nice about tonight, let me show you a couple things that I've put up on Canvas. One thing is I put a practice quiz up. Hold on. Can you guys see Canvas now? Yes, thank you. Let me see, let me become a student here real quick. So if you come down here to Unit 7, you'll see this is something we're going to work on tonight. Trig review. And then there's practice quiz 6. I was too lazy to, I already had this loaded into Canvas. It was last semester's practice quiz 7. So it's this semester's practice quiz 6. So if that bugs you, you can just cross that out, put a 6. Is everybody with me? So there's a practice quiz up. I will have the answers put up later. That quiz has been moved, of course, to next Monday. If you look on the updated homework sheet. Bow! There it is. Yeehaw. April 12th. I like it. We're scheduled to start chapter 8 tomorrow. So what I want to do tonight, since we've basically finished chapter 7, is I've got this sheet. So go ahead and, if you can, pull this up, this chapter 7 Trig review sheet. There you go. Bam. Pull this up. And I want you to work on this. So go ahead. If you want to print this out, of course you can. Otherwise, you can just do it on another piece of paper. Can anybody not access this at the moment? Can everybody access this for themselves on Canvas? Anybody not able to do that right now? Okay, all right. My class of little black boxes. Can't wait. By the way, I want to tell you this. There are 2 sections of Math 180 being taught this summer. And I'm teaching a Math 160 in case you need to take statistics. But they're all going to be taught on campus. There are several courses that have been picked to be taught on campus. I'm going to teach a stats course on campus. There are the 2 calculus courses. They're going to be taught on campus this summer. I just want to help my colleagues and myself out. We have heard nothing about how it's going to work. Do you understand? We have heard nothing about how it's going to work. And I have made it really clear to a lot of people that that is not okay with me, because I'm going to have students seeing the summer schedule, which is up now, and email me, hey, I see you're teaching on campus. How's that going to work? And I get to say, I don't know. I just work here. So I feel really bad, but I just haven't been told how this is going to work. So I'm sorry. So I just want to let you know, if you're thinking about taking 180 over the summer, it's going to be taught on campus. It's going to be in a large room. There's going to be protocols in place. It's going to be done safely. I just can't give you any specifics because I don't know them yet myself either. So any questions about that? Anybody thinking about taking calculus over the summer to get it knocked out? Yeah? Okay. Yeah, it's not a bad idea. I've taught calculus over the summer before. It's kind of nice if you're only taking that one course and you meet every day of the week. So there's no time to forget things and you're constantly building. It's kind of nice as long as you give it enough time to do all the work. It's a great way to do it. Okay, enough of that. So please go get this sheet, start working on it. I'm well aware that number 1 is a little interesting. Do what you can. It's something you could do. I know you can do it. Okay. And of course I wanted to make you all into hobbits for number 5. So pretend like you have big hairy feet and somebody's carrying a ring. And I've just lost somebody. Somebody's like, I don't do Lord of the Rings stuff, Jeff. I'm out of here. I'm Harry Potter. I'm sorry. I picked the wrong thing. Oh, somebody's chatting at me. Oh, I do. Hold on. Let me look up the dates. I'm sorry. I do know what they are. The schedule's up in WebAdvisor actually, so you could look this up. Yeah, June 14th through July 22nd. So I think this.
Okay, thank you. Because I tried to look it up the other day, but maybe it wasn't up yet.
Yeah, I don't know when it went up. I just know that today I checked and it was up. So
Okay.
today might be the first day that had it up. I don't know.
Okay.
And you'll see that there are several courses in almost every department. Some courses are going to be remote, like this, and there are a few courses that will be on campus. I think there's a certain percentage of each department that they let come on campus.
Oh, okay. Thank you.
Sure. All right, and everybody else knows what you're doing right now, right? Is everybody working on this sheet? The trigonometry review? Okay. Let me know if you have no idea what's happening right now. Okay. There we go. Okay. Bum, 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 bum. There you are. Here, let me pause.
Was good.
Sorry. What's up? Sorry.
I said, oh, was good.
All right. So there probably was not enough time to finish the whole thing. Sorry, but let's take a look here. And again, there's more than one way to do these problems. I have a certain way that I like to teach certain ideas because I know that if you get a better foundation now, things will make more sense later with some other things you do with these identities and stuff. But if you find another method that works better, great, use it. Just live with it later. And I gave us a decent starting point up here, but there are other ways to do this. So what am I going to have to do next after I've drawn this picture in order to answer this question? What do I have to do next?
Find the other side.
Yeah, find that last side. And of course, that's just Pythagorean theorem. That's now, for some reason, some people, no matter what have I done wrong if I do this? I go from there. What have I done wrong?
The 7 squared is C, not A.
Exactly. That's the hypotenuse. It should be on the side by itself. So let me call this side X. So then I know that X squared plus negative 6 squared equals 7 squared. Is that cool? And so X squared equals 49 minus 30.
Professor,
Yes.
what's different if I make it in the other way, like 7 square plus minus 6 square equal x square?
Wait. So tell me again, did you write it like I started down here? Is that what you mean?
Yeah.
So that's a huge problem. I really, so you wrote this?
Yeah.
Okay, that completely goes against what Pythagorean theorem says, right? What should be the biggest side in any right triangle? What must be the biggest side?
7.
Yes. So there's no way that I take the biggest side plus the other side squared and I equal this side. Does that make sense? I can't. It should be the biggest side is the other two sides combined. Wouldn't that just make more sense?
Oh, okay, I got it.
Good. So it's always got to be the hypotenuse is by itself composed of the other two smaller sides. That just makes more physical sense. Okay, I like it. So not only does it not make any sense, you're also going to come out with a nonsensical answer. It's not going to make any sense, the answer. So 49 minus 36, I get 13. If I'm doing that in my head right.
Yeah, that's what I got.
Square root of 13. And I know it's positive, right? And I really want you guys to remember, when you take a square root, you're really supposed to put a plus or minus. But why do I know it's positive? Because I know I'm in the fourth quadrant where x is positive. How's that? Is everybody with me? All right. So now if I want to, so let me write down here what I know. I know sine theta is negative 6 over 7. Can somebody immediately tell me what cosecant theta is without even looking at the triangle we did?
Negative 7 over 6.
Yeah, because cosecant is just the reciprocal of sine. All right, now somebody else tell me what's the cosine gonna be?
Seven rad 13 over 13.
No?
13 of square root of 13.
Square root of 13. But it's not just square root of 13, right? It's always a ratio of sides. So cosine is the x side divided by the 7, the hypotenuse. All right.
Yeah, I was just looking in the wrong place.
Okay, so cosine likes x, sine likes y, but they're always ratios, right? So the sine has the hypotenuse on the bottom, the cosine has the hypotenuse on the bottom. Okay, I like it. And remember, what's the biggest the cosine can be is 1, and the smallest it can be is -1. Same thing for sine. So you can kind of always make sure that your answer has to be less than 1 or, in between -1 and 1. Now, what's the secant going to be?
7 over root 13.
That's right. That's right. But why is that possibly going to lose you some points if you stop right there?
Because radicals
Because
shouldn't be in the bottom.
Yes. So this is going to be 7 rad 13 over 13. You have to just make that kind of like automatic.
And that's the answer I gave you earlier.
Yeah, exactly. So I knew you were going there eventually. Okay. Is everybody doing okay so far? I mean, this is sort of a nice way to do it. The minute you find the main 3 trig functions, then the reciprocal functions are easy. You just turn those bad boys over. It's in their name. So what's the tangent going to be?
-6 rad 13 over 13.
Yeah, so it'll be -6 over rad 13. And then you multiply by rad 13, and you get -6 rad 13 over 13. Yeehaw! And all right. If real quick on the side, I'm going to erase this in a minute, but if somebody gave me this as an answer on something, like they said, okay, there's the answer, Jeff. All right. There are at least 2 things wrong with this. Can somebody point out one thing? It's not the wrong answer, but it is the wrong answer. What have they not done?
They haven't.
Yeah, here's the simple thing. Look, holy shit. 4 over 6. We know that's not 4 over 6. We know that shit's 2 over 3. What about this is the slightly harder one to realize, but you have to check. You could do what with that? What can you do with rad 50?
Take out 5.
Yeah, break it down in rad 25 times rad 2. So it's 2 times 5 rad 2 over 3. So it's 10 rad 2 over 3. That's what it should be. So that's the most simplified answer, right? So giving me this answer is the same thing as telling me that the answer is 8 over 2. It's like, what? Take that one extra step. Simplify that bad boy. All right. I'm going to erase all this. Shoot, did I? Oh, maybe that's even better. Oh, there we go. Okay. Bum, 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 bum. So what's that last thing I got to figure out? What's the cotangent going to be? And here's where some people get a little confused. I'd rather start with this to make the cotangent. I just turn that over and I get square root of 13.
Yeah.
Yeah. Yeah, don't start with this crazy shit right here, right? You have to let me know if anything's not making sense. I need that to make sense. This should be the bread and butter problem. Like, give me this problem, Jeff, because this is just straight up work. Very little thought involved. You just have to know which ratios to make, right? So it's just one you can attack. All right. Well, number 2 is you got to be a little more careful with number 2. Let me see. Can somebody I haven't heard from yet tell me which quadrant is the angle in part A? Which quadrant is that in?
4.
Good. All right. So in the 4th quadrant, kick ass. And what's the reference angle going to be?
45 degrees.
No.
Oh,
Pi
my
over,
fault. 30 degrees.
Yeah, pi over 6, which is also known as 30 degrees. I like it.
Which would you rather have it in degrees or pi over 6?
Right now, I'm okay. It's kind of like the first year of a foreign language class where I'm kind of okay if you're kind of going between the 2 languages. But I'm going to try to slowly push more radians on you. Everybody needs to get more comfortable working directly with radians. So I understand wanting to take this to degrees right now because we haven't really worked with radians directly too much. But I'm going to start throwing that at you a little bit more because we need to get more used to it. But yeah, this is cool right here. I love it. And what's sine going to be in this quadrant? Is it going to be positive or negative? What's sine going to be down here?
It's
negative.
gonna be negative.
Negative. Good, because sine goes like y, and y is negative down there. I like it. See, Sokotoa doesn't do that shit for you. So negative sine, sorry, Sokotoa is fine for some things. And now this is something you have to have memorized. What's sine of 30?
One half.
Yeah, 1/2. I like it. And again, the way I remember it, since sine likes y, and 30 degrees is closer to x, sine is going to be scared. It's going to be tiny. So it's going to be the 1/2 instead of the rad 3/2, right? That's just one way I kind of think of it in my head. All right. Now somebody else tell me, what do I have to do with part B here? What's the first thing I got to figure out? Obviously the reference angle, but how do I do that with this big ass negative 480?
Add 360 degrees.
Yeah, if I go one turn around, that's negative 360. How much further do I have to go? I've still got to go 120, right? So if I go back another 120, how far away from the x-axis am I?
60 degrees.
30.
No, 60.
Yeah, 60.
All right. Right? Is it pretty cool that? Because the x-axis back there would be 180. So if I just go 120, I'm 60 away from it. That's how I get the reference angle. Is that cool? I mean, I know this is something that you've never really done that before in another class, but it isn't like insane to try to get a hold of. Just you gotta let me know if it doesn't make sense. Is cosine positive or negative in the third quadrant down here?
Negative.
Yeah, because the x-axis is back this way. It's negative. Cosine goes like x. So this equals negative cosine of 60 degrees. And again, I really want you guys to not forget the angle at 60, it would make the same triangle here that it makes down here. So of course the sides of the triangle are going to be the same length. It's just that it's going to be negative because the x piece is going backwards. So that's why it's, once I figure out the reference angle, I got it. And so what's cosine of 60? It's kind of the same thinking as this was.
1/2.
Yeah, because again, cosine likes x. 60 is far away from the x-axis. Poor little dude is scared. So he's going to be a little tiny 1/2. All right. Poor little dude. Do you guys, anybody out there look at something over 4 and understand it's going to be in reference to what degrees?
45.
45. So anything over 4 is a 45. Anything over 6 is a 30. Anything over 3 is a 60. Right? Yeah, there. So obviously, so this one, where am I going to end up? Negative 5/4. So I'm going to go back a whole pi, then how much extra? We basically just said it, but another 45 degrees, right? All right, let me stop for a minute. You got to let me know now if something isn't making sense. You have to let me know. Okay. Now, one of my favorite ways to handle this kind of thing. First step is, what is cosecant related to?
Sine.
Yeah, so
Yeah.
it's going to equal 1/sine of negative 5π/4. Now, I know the reference angle is π/4, and what's the SIGN of sine up here? Is it positive or negative in this quadrant?
Positive.
Positive, because sine goes like y, and y is up here, so that's going to be, so this equals 1/positive sine of π/4. I like it. And what's sine of π/4?
2/2.
2/2. So do you guys remember what I said about when you have 1 divided by a fraction? It's just the reciprocal of the fraction, right? So this is 2/rad2. This is going to take a minute. Times rad2 times rad2. I get 2rad2/2. I get rad freaking 2. Shit. That was a trip. To be really honest, let me see if anybody's noticed this at all. The value we use for sine of 45, yeah, 0, is really 1 over rad 2, but we just rationalize the denominator. So that's why it makes sense. If it starts off as 1 over rad 2, what's the reciprocal of that? Rad 2, holy shit, right? But since we started with the rationalized version, it made this kind of grosser than it had to be, but oh well, nothing we can't handle. Okay, I like it. I do worry about you guys. You guys all understand that you can ask me anything. You can even say, Jeff, I know you hate SOHCAHTOA, but could you explain it to me? And I would. Do you understand? Because I am your teacher and I want you to understand shit. So you can ask me anything. Don't feel that you can't. All right. Feel like a parent. You can tell me anything. No, I can't. Get out of my room. All right. So I want to find all 6 trig values of A. And the nice thing is A is in the base, right? That's the only thing you have to be careful about when you're using the method I'm trying to tell you, right? That sine likes Y, cosine likes X. So of course, this is a lot like number 1. This is exactly the same problem as number 1. What's the first thing I've got to do?
Yeah, find the bottom there. Or
Yeah.
X. Yeah.
Like it. So then I've got x squared. Let me see. Let me do this over here so I got some more room. Get out of there. Let me do it over here. X squared plus 11 squared equals 19 squared. What the shit is 19 squared? Let me see. 400, 360.
361.
Yeah, thank you. I got there about the same time you did. Minus 121. Is that cool, everybody? 11 squared, 120.
Yes.
Track that bad boy over. So then I get, you can do it, Jeff. 240?
Yes.
Okay. So I get the square root of 240. I don't have to worry about any negatives in this. Do you notice number 3 is not like an angle in a quadrant? It's a physical triangle. Do you guys understand what I mean by that? Like, I really want you to kind of get what I'm saying right now. Was this a physical triangle? Not really, because this side has a negative length. Does that make any sense to anybody? This is not what I would call a physical triangle. It's just sort of a visualization of what the shit's going on. This is like a real physical triangle. The side cannot be negative. It's not a problem where I'm in the 3rd quadrant or something. No, it's just a triangle laying on the desk. And I'm like, shit. All right. So can I simplify this? It looks like I should be able to simplify this, right? In fact, I can simplify it more than you might think, I believe.
16 times 15.
Yeah. This is 16 times 15, so I get 4 rad 15. And again, just to let you guys know, you can obviously divide 240 by 4, right? And why would 4 be a number I try? Because I need to divide it by something I can square root. Now, I'm kind of having faith that you guys remember how to simplify radicals, right? So if you have any issues with that, you got to let me know, and we could talk about simplifying radicals, because you're going to see a lot of that with this trig stuff. But if I divide by 4 because it's a square rootable number, I get 60. But 4 can go into 60 also. So if I divide 60 by 4, I get 15. So 16 times 15. This is the 2 4s that worked. Square root of 16 is 4. Square root of 15 is I don't know. 3rd base. No, just there it is. All right. So now I can find all the trig values of A. So sine of A, what would sine of A be? It's going to be a nice
11 over 19.
Yeah, kick ass. It's the nice whole sides. None of that radical shit. But then here comes cosine.
4 square root of 15 over 19.
Exactly. Because it likes X. I like it. And then tangent.
11 over 4 times square root of 15.
I like it. And then you got to multiply by square root of 15. Woo! All right, let me stop for a minute. I've left myself no room. Oh well, I can erase this stuff. This wasn't really necessary. Get out of there. All right, and now see, I've got the big three. I've got the big three, so the other three are easy. They're just reciprocals, right?
Correct.
So if I want to do cosecant A, that's 19 over 11. What do you do? If I want to do secant A, that's going to be 19 over 4 rad 15. I got to multiply by rad 15. I get 19 rad 15 over 60. So everybody go with the 60. 4 times rad 15 times rad 15 is 4 times 15 is 60. And then cotangent A, I'm going to be smart. I'm going to go back to this. So then it becomes 4 rad 15 over 11. Does that make sense? I'm trying to help you guys out with some of the stuff that makes these harder than they have to be. Don't take the rationalized version when you're trying to reciprocate it. Then you have to undo that rational. Oh my God, this is disgusting. Just go back to before you messed with it, right? I really hope that makes sense. All right. Here, let's do number 4. And then I think, well, let's see. Let's see if we can make it through this. Obviously, what's this angle here?
$47.
Yeah, it's got to be the rest of it to make a full 180. Now here I can't use Pythagorean theorem to figure out the sides, right? That's the whole point. So, but it's up to you. Now look what I would do. For all those people that like SOHCAHTOA, I just do this. Now my angle is in the base, the 43 degrees, right? So how am I going to figure out this side? I'll call that Y, and I'll call this H. So now you see why I call this Y, because it's the Y piece. So what can I do to figure out the Y?
Is it the law of sines?
Don't say law of sines, because we don't know what that is yet. But just use the sine function, right?
Oh, fair enough.
There's a thing, I don't know if you know this, but there's a thing called the law of sines that we're going to learn later that's related to the expanded Pythagorean theorem that will work for all triangles. So that's coming later, the law of cosines and the law of sines. So here I got to do, if I do sine of 43, that's the degrees up there, it'll be Y over 20, I'm sorry, why would I do sine? Jeff, you're silly. Why is sine not going to help me out? Because I know, yeah, I know this. I want to know this side, and I only have this side. So which trig function should I use? Not sine. Which trig function should I use?
Cosine.
Not cosine. Do I know the hypotenuse?
No.
I want to use
Tangent.
any trig function that relates to the hypotenuse. So I got to use tangent is a good one. Tangent of 43 would be this side over that side. So then I know Y is 24 times tangent of 43. And then you throw that in the old calculator and see what that is.
Can you take the sine of 47 also
You could
to
do.
find the hypotenuse?
Oh, I see. Yeah. But I just picked the Y. I wanted to figure out what Y was first. But yeah,
Gotcha.
to figure out H, I'm totally with you. You could do the sine of 47 because then, let me see if I can make you guys all sick. If sine of 47 would be 24 over the hypotenuse. I love it. Perfect. So we'll do that next. So if you throw that in the calculator, what do you guys get? You should get just under 24, I think, right?
22.38.
22.38? Okay. And then let's do the suggestion. Somebody else said sine of 47 is going to be 24 over the hypotenuse. So that means that h, now I had some people doing this math wrong. What's the quick way to solve this for h? If I multiply h up, I have to also do what with this?
Right.
Divide by it.
Divide it down. Yeah. So some people were somehow getting this to magically multiply. That doesn't make any sense. Right, two, two, right, two. 1.4, so like 1.5 or 35. I'm going to say 35 something. Maybe 33. I don't know. I'm doing it in my head, so.
That's 32.8.
Oh, okay. See, I can live with that. 32.8. Okay. So let's do this. I have a feeling that most of us didn't reach number 4, definitely not number 5. So let's do those first thing tomorrow. So we'll end for today. Don't forget, I put the practice quiz up on Canvas. You can take a look at it now if you want to. Maybe don't take a look at it until you've done more of chapter 7 homework, right? And we'll finish this up tomorrow. So that's it for today. Let me know if you need some help, if you want to hang out afterwards. Otherwise, you're free to go. And I'll see you tomorrow.
All right, have a great night.
I'll try.
Oh, Professor,
Yes.
can I ask you how you got 22.38? Because I got 35.96.
Oh, I'm sorry. On this one here?
Yeah, number 4. No, not here. Like the tangent 43.
Oh, up here.
Yeah.
So how do you get 22.38? Is that what you're asking?
Yeah.
All right, so let me see. I kind of crowdsourced that. So let me see what I get. Tangent 43. Yeah, I get 22.38. So what are you putting into your, what are you getting? What are you getting out? What
Like
are you,
I just put 24 times the tangent 43.
and what'd you
Actually, I'm doing it on my phone right now.
get? Oh.
Yeah, because I'm not in the home. They
So-
give me 35.96.
No, you get negative 35.96, right?
Yeah, negative 35.
Because you're not in degrees, you're in radians. You have to change it to degrees. You have to change the setting to degrees. I'm not sure how you do that if you're doing it on your phone.
Oh, okay. Okay, but if I do it in my calculator, it's gonna work, right? It's gonna be
As
22
long as
point.
it's set to degrees. So let me show you real quick.
Oh, okay.
I'm not sure what it's going to look like. Hold on. Let me wake up my calculator real quick. All right, here we go. Come on. I think every time I open it, it takes a little bit longer. All right.
Sorry about that.
No, hold on. It's okay. I feel bad because it's taken my computer a long time. Here we go. So right up in here,
Yeah.
mode. See right there's his radians degrees.
Yep.
So if I do 24 times tangent of 43 right now, it'll agree with what you got, right?
Yeah.
Because I'm in radians. Oh no. So it thinks that the angle I'm giving it is radians when I know this is not 43 radians. That's 43 degrees. So now if I do it, I get the right answer.
Oh, okay. I got it.
All right.
You just should be change it to degree, right?
That's right. So if you're using your phone, I don't know, somewhere there's a way to change it from radians to degrees. Normally there's like a DRG button or something like that.
I don't know. I can see it.
I don't know.
Okay, never mind. I have my calculator, but because I'm not in the home, that's why I'm using my phone right now.
I gotcha. Okay.
All right. Thank you so much, Professor. Have a
You're
great
welcome.
night.
See you. You too.